I'm going to tell you this unit or this section, one of the most important sections. I know I've said that with the first derivative test, but it actually ties into this. The whole first derivative test really is what this is all about. And what we're doing is we're connecting a function and its first and second derivative. And that's what you're going to be doing for a majority of that AP test. You may be looking at the first derivative and telling things about the function. You may be looking at the second derivative and telling things about the first derivative or telling things about the function. And when we get to antiderivatives, they're going to do this all over again. Just now you know how to go back and forth between them. And so really, really, really important you get this down. So one of the big things that we learned is let's just focus on f prime right now. So for f prime, what does f prime tell us about f? So if f prime is positive, then that means that f is increasing. And that's kind of the whole point. We use f prime to figure out stuff about f. F is kind of the main part of the show here, right? F is the center, the spotlight's on f. But we're using f prime to figure out, hey, is it positive or negative, to know if f is increasing or decreasing. If f prime is negative, then f is decreasing, because that's the slope, right? And then we use that to figure out maximum and minimum. Remember, that's where we got that first derivative test from. You know, if you have that first derivative test and it goes positive, negative, positive, then we know our function's increasing and then decreasing, getting us a maximum, then decreasing and increasing, making that a minimum. So it's all based upon this. This is really the centerpiece right there, the f prime. What does it tell us? And it's like every year people get so confused because they think there's so much going on here. But it's actually quite simple. F prime simply we use to tell us those two things. Is f increasing or is f decreasing? And we use that to determine the maximum and minimum. We use we have the critical points going on here. You know, when f prime is 0, we have horizontal tangents. So it's going to be a critical point. All right, there's one more thing f prime can tell us about f. But we actually don't really use f prime for it. But we're going to talk about that. So here's one thing. Let me just see if I can just kind of mark this off. So here's the second thing. So f prime. If f prime is increasing, then that tells us that f is concave up. Right? So if f prime is increasing, so it's different. F prime is positive and f prime is increasing is two different things. F prime being positive just simply means if you plug something into the function, you get a positive number out of it. That's what it means. You know, if you were to take a look at the graph of it, you know, let's just say this is the graph of f prime. It's just a horizontal line. This is the x-axis. So f prime is positive because it is above the x-axis, meaning the y values are positive, right? If you were to take a look at these y values, they're all positive. So it's not increasing or decreasing here. F prime is just simply positive only because it's above the x-axis. That's totally different than if I were to give you the graph of f prime. Now I'm actually going to draw it below right here. Let's draw it down here. So f prime here is negative because it's below the x-axis. But notice that f prime is increasing. How do we know that? Because it's going up. This is if you're given the graph of f prime. If you're given the graph of f, you just look at it and just look at where the maximum and the minimums are at. Look at where it's smiling and frowning. That's where you know your concavity. But if you're given the graph of f prime, it's different. If this is when f prime is positive, when it's above the x-axis, this one's not increasing or decreasing. But this one down here, even though f prime is negative, it's increasing. And I'm using this point to show you that f prime being positive has nothing to do with f prime increasing. Right? So if f prime is increasing, that means that f is concave up. Now, how do we know if f prime is increasing? Well, we know that by looking at its derivative, right? Because if f prime's positive, that means f is increasing. So that means if the derivative of this is positive, then that means that it's increasing, right? So f double prime is positive, then f prime is increasing. And that tells us our concavity. Similarly, if it's negative, then we know it's decreasing. So the main thing with this lesson is we're going to be looking at, the graphs of f, f prime, and f double prime and getting the idea here. So really just what we were talking about before, if it's above the x-axis, it's positive. If it's below the x-axis, it's negative. So you're really looking at intervals here. So if you look at this interval, so about right here at this spot, this is the graph of f prime. And I haven't really looked at this graph yet, but you can see it's positive. Even though f prime is decreasing, it's positive because it's above the x-axis. And so if we look at f, it should be increasing. Why? Because f prime is positive. So look at this. Is it increasing? Yeah, it's going up on that interval because f prime is positive. And then it goes negative, so we're going to see it go down for a bit. And then right here, it's positive because it's above the x-axis, so we see it go up again. Then it's negative in that little swoop, so we see it going down for that time. And then it's positive, so it's going up. Now, you could use this graph also to determine concavity. But let's go ahead and go through that one more time. So it's positive on this interval. So you can see on that interval it's increasing until we get to this spot. Let's just section it off like this. And you can see from A to B that we're negative, which means from A to B on this graph, we're going to be decreasing because this is F, right? And then from B to C, we're positive again because we're above it. And so you can see our graph is increasing again. Then from C to D, I don't know what I put from C to C, it's negative again, so we're decreasing again. And then it's positive from there on, and you can see that it's increasing. Now we could also use this graph to tell concavity. F prime is decreasing all the way till right here between A and B, and you can see that it's concave down that entire time to A to B, to about right there, right in between A and B, right in that spot right there in the corner of this cursor. You can see it changes to concave up, and you can see our f prime now starts to increase. So that's one way you can tell. Or if you have the graph of f double prime, when it's negative, it's concave down. So you can see that right here when it's negative, we got concave down. Then it's positive because above the x-axis. Now we're back to concave up. So different ways to determine that, but it all has to do with right here. That really should box that in. Okay, so let's look at these. So what's an appropriate calculus-based justification for the fact that f is increasing? Now we could look at f and see that, hey, it's going up, but that's not calculus. We need to look at its derivative. And it's increasing. Why? F is increasing because its derivative is positive. Notice the derivative is above the x-axis, so f prime is positive. That's the calc reason why f is increasing. What's an appropriate calculus-based justification for the fact that f is decreasing? So f is going down. Yeah, we can see that. And we can say that as the x values increase, the values of f decrease, but that's not a calculus-based justification. We're going to use f prime. F prime is negative because it's below the x-axis, so that would be our justification for why it is decreasing. What is an appropriate calculus-based justification for the fact that f has a relative minimum point at x equals c? So let's look at the derivative. If we're going to do a first derivative test on this, our derivative is going from negative, because below the x-axis, to positive. And so that would mean that that would be a minimum, right? If you were to draw that, the f would be decreasing and then increasing. We can actually see that right here in the graph. It's decreasing and then increasing. So that's why it's a minimum, because f prime changes from negative to positive. So let's see if we can find that. F prime crosses the x-axis from below to above it. So it goes from negative to positive, right? So that's going to be C. Once again, guys, such an important section. Really review what we went over here and try to really understand that and grasp that. And it's going to help so much as we continue these assignments later.